Alright, friends, welcome back to another exciting edition of Mr. Hull's Virtual Classroom. We're going to be on page 259 today, talking about dividing polynomials. So please feel free to join me, and we're going to get the party started. And again, we're going to be on page 259, if you would. Alright. So we've talked about dividing polynomials when we've had, divided by variables, but now we're going to be talking about adding a variable and a constant, dividing into the entire term. So if you would, go ahead and look on example 1 with me. Example 1 is actually quite simple. It looks a little deceiving at first, but it's fairly simple. So we are given 3x y3 plus 9 all over the entirety of 3xyz. Let me pull this up a little bit so you guys can see it a little better. Alright, something I want you guys to really notice here is addition signs, subtraction sign, like terms. One thing that we went over, we even did a lot of this when we were doing ACT practice, we talked about when you're dividing variables on the bottom, what do we do to get rid of exponents? Don't we subtract them and try to move them to the top, right? So one thing that you can do, since this has got 3 different polynomials, you can take the 3, put it to this equation, it can go to this equation, and it can also go to this equation. Alright, with that being said, I want to flip over to another page and we're going to try to work them out individually. Alright, so let's take our first one, which said it was 3x2y3. And we'll put it over our 3xzy. Okay. So what do I want to do? I want to get rid of my x. If I want to take the y if I can, I want to take the z if I can. Alright, in order to do so, I need to go ahead and start doing some subtractions. So I can take the 3's and they're gone, right? So can I subtract any x? I can subtract this x, and this actually makes this what? X to the first, right? And then I can take the y. Is there any y's? Yep. And this becomes y to the second, and this becomes what? 0. So if I've subtracted every portion of this, now what do I do? I can rewrite it as the 1x we had left. How many y's do we have left? We had 2 y's. And there was no z's to subtract. So this is the first portion. Okay? So write that down. Now let's do the second part of it. We had 9x to the 5th, y to the first, z to the second, all over the same, which was 3xyz. Alright, I want to get rid of what? The bottom. So I'm dividing the constant into the top, but I'm subtracting my what? My variables to get rid of my exponents. So 3 goes into 9 how many times? And I'm going to write it all right over here. 3 goes into 9 3 times. I can subtract this. This becomes x to the 4th. This x is now gone. Y to the first and y to the first subtract each other, so y's are gone completely. Z to the second minus z to the first gives me what? Just z to the first. So what am I left with? 3x to the 4th, z to the first, right? Is this over anything? No, because we canceled out the entire bottom. So this is the second portion of our answer. Okay? Alright, flip over to the next part. We have, now this is a minus 1x to the 4th, y to the first, z to the 5th, all over the same problem we've been using, 3x, y, z. Alright, So riddle me this. We don't have any constants on top, right? So we have to at least keep this one on the bottom because it is positive. You cannot have a negative constant on the bottom. You can have a positive, but you cannot have a negative. All right, so my question is, since we've been subtracting the top, what's going to be our x to the fourth minus x to the first? Well, that's going to give us what? X to the third. And then we're going to have y minus y, which is what? If these cancel out each other, that's just 0. And this becomes z to the fourth. Alright, so we now have the problem completed. So we just have to rewrite it. So what we're going to do is take everything that we just found. Alright, and here's our 3 answers just so you can see. This is 1. And this is going to be, I don't know if this is moving to 2. And this is going to be our 3rd. Okay, so I'm going to write them down here, what our answers look like. We have x to the first, y to the second over z, plus 3x4z, minus x 3z4 over 3. And that is what our entire problem should look like. So, if you notice how we broke that up into 3 different portions just to get one answer, it makes it so much more simplistic than trying to do it, you know, as one big, which I think is just jumbled problem. Alright, go ahead and look at example 2. Example 2 is going to be talking about dividing polynomials. So, what we're going to do here is we're going to take, and I'll probably have to switch paper just a little bit because this is it's going to be quite a long problem here, but and also have this worked out, and I'll take a picture of it and email this to you. Alright, so basically what we're going to be doing is trying to get the top and the bottom to come out to 0 to see if this is going to be, if the zeros indicate that this can be a factor of the dividend. So, you know, typically you might have, the most that we've done that I can remember is just, you know, you might have 1x divided into it, or, you know, 2x into something, but now you've got 3 different parts of an equation trying to divide into this entire polynomial. So what we're going to want to do here is divide by the highest term, alright? And when I say divide by the highest term is I have to figure what number can I multiply this by that can give me something in the middle here. So I think what I would do is I would probably try to do x to the first for all these. Because if I do x to the first, I can put x to the first here, and that would give me 1x to the third, 1x to the second, and then just -2. Okay? Now what I want to do is I need to figure out, you guys remember when we did substitution and elimination?